Hi, everyone. So this is a very interesting talk for me. Usually I give fairly technical talks on databases. And over the last 8 years, I've been managing larger and larger database teams and recognizing that the paradigm of being a DBA has been shifting along with a lot of other paradigms in IT. And wanting to be able to give advice to DBAs who are already DBAs, people looking to be DBAs, and people who are working in teams with DBAs on what the role is morphing to, is really what this talk's about. So it's not about scaling databases. You can hire OmniTI for that, but it really is instead about paradigm shifts and fitting into the modern world of IT and tech as a database engineer, as opposed to as a database administrator. I try not to talk too fast, but I will. So raise your hand. Just tell me if I'm talking too fast. Raise your hand if you want to ask any questions or interject. We can do it at the end, but I also don't mind talking in the middle. My sense of humor is quite dry, so if I say something confusing, it's probably a joke, and I would just appreciate a courtesy laugh. It helps us all get perfect. And I do curse a little bit. My CEO has been trying to get me to curse less in conferences, so I will only say fuck twice. Not counting that one, and we'll just go from there. So, database engineering and not database administration. How many people here identify as database professionals? Awesome. So I started as a DBA way back in the late 90s to date myself, and this is how I always felt, right? I was a gatekeeper. I kept everyone out of my databases, preferably just no applications, no developers, just a nice quiet database was my ideal world, and I worked towards that. I was a master builder. I built crazy-ass, giant, special snowflake Oracle on 4 Cray-linked SGI servers with custom configs you would never see, and no one could ever rebuild that server again without some magic. I was a superhero. I could go into an environment where the database was crashing. I could add an index. I could show someone how to change one configuration in a file, and suddenly you could reduce latency by 500%. You could reduce resource consumption by magnitudes, right? I was a superhero. It was also siloed. No one ever got me involved early enough. I was never part of the planning sessions. I was not talking to engineers when they were thinking about the architecture. I was the one they tossed the DDL scripts to and said, could you review this and run it today? Or the person who got the call when the new queries that were never reviewed or even talked about in terms of data planning went into production and set everything on fire. And finally, I was specialized. No one wants to be a DBA except DBAs. No one else. Everyone's like, I don't want to touch the database. It's a horrible, horrible thing. And it's true. No one wants to touch the database. So what is a database engineer then? If that's an anti-pattern, if this administrative component is something of the past that we are morphing from, what is the pattern for being a database professional? I use engineering, and when I say engineering, it tends to be these 4 things, right? It's quantitative. Everything we do is approaching the scientific method. It's measurable. It's interdisciplinary. No longer can I focus and specialize specifically on a database. I need to learn all kinds of things around it and the ecosystem. It's results-focused. It's about the business. It's not about protecting the database. It's about how do I get features out there faster in a world where feature velocity is everything, and it's repeatable and it's code-driven. So just a couple of quick taxonomies so we all understand what we're talking about, or at least what I'm talking about in terms of this. So systems engineering, right? This is somewhat architecture. It's designing complex systems for the complete life cycle of those systems. This is where we translate a business idea, a set of features, into a large distributed system, a very complex one generally. The focus as a systems engineer is on communications between all of these subsystems, whether it's microservices, it's event-driven architectures, it's about resiliency, it's about being flexible for agile development teams where feature sets can change, pivots can change regularly, and it's about being prepared for that or being interoperable. And finally, it's more and more, it's about creating a system that generates metrics, fuck tons of metrics, and giving that back to the business so they can make those rapid pivots, they can make those rapid changes. Operations engineering is the next step. And just like always, as database engineers, we're part of almost every group, right? Operations engineering is about designing processes. It's about allocating appropriate resources, about the tooling and the ecosystems to keep that system running and generating the data to continuously improve and grow it. And then we have the database engineer. We participate in all of it, right? At this point, we're participating in the systems engineering components, the operations engineering. We're part of Agile development teams. We are a shared resource that's providing depth in terms of how do these different data stores work, how do they interact and complete through it. We teach and support and mentor engineers on the nuances of data sets, on the nuances of optimizers and queries and components they'd rather not be a part of. And we anchor every team with our expertise. So yes, shared services for cross-functional teams, for ops teams, for architects. So at a high level, that's what the taxonomy. And so now, what got us to there? What got us from being the superheroes, the master builders, to engineers who are building what is ideally repeatable, measurable, multidisciplinary, large distributed systems? So what are the paradigm shifts that have occurred? I think some of you have probably heard a lot of these. I promise I will talk about DevOps on a very small amount only. But this is a nice pyramid that I think of the 5 different things that really impact database engineers and have created the modern role. First, polyglot persistence. It's no longer the case. I can manage and understand my SQL, and that will be enough for the entire ecosystem, right? Suddenly I have to manage Hadoop stores. I have to manage document stores. Ideally, my job becomes, instead of just trying to be an expert on the databases, it becomes trying to make sure developers aren't throwing in 20 different types of cool new database engines without really understanding the whole ecosystem. Then there's virtualization and cloud environments, infrastructure as code, continuous delivery, and finally, the DevOps culture. So as I was saying with the polyglot persistence, suddenly, and if you look at it as the concept of a T-shaped engineer, right, you've got your depth, and then you've got your breadth. At the depth, it suddenly has to get a little wider because we do have to understand what document stores are. We have to understand key value stores. We have to understand CAP theorem and then to tell people, well, CAP theorem is bullshit, and help them pick all of these different steps to build what tends to be a very complex data store ecosystem throughout. At this point, data is part of a pipeline, and we have to manage the full pipeline. And we can't always predict what kind of data is going to come in, so we have to be prepared for that. An example is, this is just a simple Lambda architecture. It's simple, right? That you would find in Amazon. And as DBA engineers, we have to be able to jump in anywhere in there and help people understand where to put data, why to put data, how to access the data, and what that flow looks like. Then we've got virtualization in the cloud, and virtualization is not new, obviously, but it is becoming much more common and much more a part of everything we do, whether it's a public cloud like Amazon or Google Cloud, or it's something private like Eucalyptus, or it's a hybrid. More and more, we're starting to use data stores on virtualized equipment. How many people have made the vow at some point, whether drunk or sober, that they would never run their database on a virtualization instance? I did, and I said no. I remember the first time someone told me I had to run my database on network disk, and I almost hit them in the face. You don't want to do it, but now we're starting to get to the point where it's ubiquitous, and suddenly what used to be, I would never run on an NFS store or a NetApp or anything like this. Now we're getting to the point where we can run entire database clusters on ephemeral storage on Amazon without even running it on persistent data at all. And it actually works, and it works well. So that's one of them. The other is commodity hardware, forcing us to scale horizontally. We're not scaling up, we're scaling out, which means, of course, sharding, which means, of course, marketing people selling us auto-sharding, which, of course, means us then learning that auto-sharding is a lie. It's like the cake. It's a lie. It doesn't work easily ever. And it forces us to design for failure. It forces us to ignore the fact that MTBFs are increasing. Our mean time between failures are getting shorter and shorter, and instead look at how we're managing those failures, if they're invisible, or if how we're optimizing for recovery faster and faster. Even the databases are no longer something that we care about if they crash, right? They cannot be special snowflakes in these environments. You should be able to walk up to your database master and shoot it in the head and not worry about it. And of course, you're starting to deal with new storage, like I said, ephemeral. How many people here have run a production data store in Amazon on ephemeral storage? Right? It's pretty fun. It's like driving 180 miles down the freeway, surrounded by other people going 20 miles an hour. But it works, and it gets you there if you do it right. Suddenly, we're managing our infrastructures with application programmatic interfaces and scripts that can pull those resources out, rather than logging into boxes and attaching everything manually, building it up. And we're working in continuous deployment pipelines where we are actually enabling people to push features out multiple times a day because we're in these virtualized environments. And that's another fun one, right, is continuous deployment. That's another one. If you had asked me 4 years ago if I was willing to let developers push things out into the databases on a daily basis, I would have quit and worked at McDonald's and just said, no, I don't want this horrible future world, this dystopian future. But it's here, and I would imagine we probably have a few folks here who actually run production databases in continuous deployment environments. Hands? No? Oh, a couple brave ones. And it can work, but it requires, again, as a database engineer, we're not a gatekeeper anymore, right? Our goal at this point is to ideally enable faster and faster interactions with the database, safer deployments, the ability for us to know when changes need our attention rather than saying we need to review everything. At this point, if you look at the theory of constraints, we are the constraint. And if we want to exploit that constraint, that's how we can make continuous deployment an idea, or take it from an idea to reality. Infrastructure as code, which goes right along that. Suddenly, we're building software to manage our systems. And for some database engineers, that's a bigger deal than others. I was never a software engineer or a coder in my life. I learned stored procedures and shell scripts as a DBA, and I was never very good at them either, but I got the job done. But now, more and more, we actually find ourselves having to understand the details of scripting languages, even object-oriented languages, to just make sure that we can build these large and manage these large distributed systems. But what does this do? Well, it forces us to create standard systems. Again, no special snowflakes. Suddenly, change management is changing configurations and destroying a server and creating a new one in an immutable environment versus updating config files, changing memory. Forces us to code if none of us are or some of us are not coders, and it forces us to start thinking about not building database clusters anymore, but building platforms whereby engineers and architects can self-service their own data stores. And of course, our changes become deployments. No longer do we work outside of the deployment cycle, but we work within it. Any questions so far? Is anyone horribly disappointed by the non-technical nature of this talk? Awesome. So continuous delivery, the next paradigm. Again, at this point, our systems are part of source control. Our my.confs, our init.auras, whatever others we're using are actually checked in, and they're artifacts that are involved in massive deployments. So we can't be gatekeepers. We have to be teachers and educators. And our job becomes picking the right platforms, picking how to architect them, making sure people understand the standards to use, and then helping them and making sure, of course, that we're compliant. And then finally, the last one is DevOps itself. And in a DevOps culture, we find some amazing ways to exploit the constraint of the DBE, because we're always going to be one of the key constraints in any environment. No one can afford to have one database engineer for every Agile team out there, and if they can, they really shouldn't. So suddenly we have to figure out, how do we work within this? Lean manufacturing techniques, using Kanban, using the ability to service multiple emergent projects and opportunities as they come, picking our battles, letting others make some decisions, get into those systems. Tighter feedback loops means people have to be able to see the results of their changes right away, which means suddenly everything we build has to be instrumented and measured at real time so people can understand their impacts to the database. And sometimes it's okay to let them put changes into the database and us to measure the impact after, because that gets the feature out in time. All of these experimentations require a lot of empathy. They require a lot of tight collaboration in teams. And this is my favorite slide because it's true, right? Database engineers were always DevOps. We were the first ones, right? We're OG, as it were, because we were a part of the development teams and part of the operations teams. We were the middle, the glue. It's just instead of empathy, we were assholes, right? We were like, I hate the developers, I hate the sysadmins, I hate all of you. Leave my databases alone so I could sleep one night. And so now we're just pivoting it, and we're still in the middle of it all, but instead of being assholes, we're really nice about it. And we're learning to be a little more empathetic. So as I said, T-shaped, right? Today's database engineer has not only the specialty, the depth of needing multiple persistence tiers that they can master, and I don't think any of us can become extraordinarily competent at more than 2 databases at a time. I'm sure there are some really special smart people, but you can understand the concepts more broadly of all those other systems. And more, just knowing one isn't going to get you through the day. But then, of course, you have to focus on the breadth of it. And here there's 2 levels, right? There's the cross-technical disciplines that you're going to look at. Networking, for instance, an amazing one that really every DBE needs to know in these distributed environments in ways they didn't need to know when they had giant big iron sun servers running monolithic data stores. Again, the scripting, software development, how to work in continuous deployment environments, even getting into data science and analysis. And then there's the other boundary crossing components. These are the soft skills. How do I work on an Agile team? How do I do leadership? How do I do project management? How do I manage 5 teams relying on me to do all of this work? And how do I communicate them effectively? I don't know if any of you have ever seen my talks before, but there is a huge smallness to the amount of My Little Ponies in these slides. Most of my slides tend to have at least 1 My Little Pony per slide, if not more. So this is, for any of you who are discouraged by My Little Ponies, this is a good talk for you to be in. This is my only one. What is the manifesto for the database engineer? One, it's all about the mission, right? Whether that mission is your business, whether that mission is a project you're working on, a startup, anything else, that is the whole purpose why you exist. Protect the data, more importantly than ever. And here in this case, it's figuring out what data to protect. In the past, I just made sure that every piece of data that came within my ecosystem could be backed up, could be restored. I knew at any point in time that it could be restored. But now we're going to have some data that we actually don't care about. And we have to understand that and figure out the data we do have to care about. Suddenly we have some systems with incredibly different needs for data recovery than others. But ultimately it's still the manifesto of the database engineer to protect the data. If you can't restore the data and you didn't expect that, if that wasn't a design feature, then you have not done your job and you should quit. Eliminate waste. Again, you are a constraint. More and more you're a constraint to getting features out of the door as the database engineer. So you have to eliminate every piece of what you do that is not necessary. That means automation, that means delegation, that means sharing resources, mentoring and teaching, all of this. Data-driven decision-making. Hopefully everyone here already does their troubleshooting and their diagnostics and their experimentation with the scientific method, but more and more with these large systems and distributed systems that we're working on, we must work off of data, which makes sense, we're database engineers. And databases are not special. That for me was the biggest thing that I heard a few years back that really sort of shifted my paradigm, was the idea that nothing is special, right? If I can't get rid of my master in the middle of the day, peak traffic time and survive it, then my system is not production ready. And we should never feel like we can't do that, which is why it's really fun and exciting to run on ephemeral hardware and see that you can actually keep a system. As a system, you can keep that uptime, that SLA hit, even though as an individual component, you've got incredibly fragile components. And finally, eliminating the barriers between your software teams and your operations teams and your testing teams and your business teams. That's what we do as database engineers. We are DevOps engineers, for lack of a better word. Any questions so far? Pace okay? Cool. So I like to then take what was very theoretical and talk a little bit about what that looks like in the day-to-day life of a database engineer, the craft. So my friend Charity gave me this. I'm blatantly stealing it, but I'm at least saying Charity invented Maslow's hierarchy of needs for databases, and I thought it was the most brilliant idea ever because it gives you an incredibly nicely structured approach to basics to advanced of how to build and maintain database systems. So again, if you're not familiar with Maslow's hierarchy of needs, first you have to take care of your physiological needs, then you can take care of your safety needs, then your love and belonging, then your esteem, and then your self-actualization. So in the craft of being a database engineer, if you look at this way, you're able to point by point grow a database architecture to full maturity, which if you're in a startup world and you're dealing with limited resources, is incredibly useful. So the first thing we do in the craft is we focus on the physiological needs of the system. Does your database run? Can you connect to it? Can your applications query and write whatever they need to do? Is it stable? Is a nice physiological basic need of the system? Can the data be backed up and restored to a point in time? And can your basic levels of service that are required of the system be measured and monitored and alerted on? Then we have the safety. At this point, the original system's built, people are using it. We know when it's up or down, and it's nice. Excuse me. So where do we go next? Well, at safety, do I have multiple copies available and online to make sure that I can deal with anything that happens and could come up? Is failover built, documented, and tested? Am I doing geo-distribution if my SLAs require it? Can I detect corruption? Not just can I recover a database, but if the data silently corrupts, can I somehow find out about that and check it before all of my backups are corrupt? Is access managed through appropriate separation of duties? Is the data protected and only people who need to get in actually do it? And people who need access to the data given the tools they need to safely do it? And is the data encrypted as is appropriate, whether at rest or at transport? So that's the safety level. So that's our next job as database engineers. Then we go into the love and belonging phase. This is where we start to make sure that other people in the environment can use and expect and interact with our systems in appropriate ways. So are we integrating this with continuous integration and continuous deployment? We're testing, and are we helping our engineers and our QA engineers get appropriate data sets to test? And this is a great chance to solve number one, which was our backups and recovery working, because if we're building our backup and recovery into our day-to-day processes, then we can achieve love and belonging as well as physiological and safety all with one process. Are we using automation and orchestration so we don't have special snowflakes, so we don't have silent configuration differences between systems that are going to bite us in the ass? And is everything scripted so that it's repeatable and manageable? And then finally, is that managed through something like Chef, Puppet, any of the systems that will do that? And then we get into the esteem level. So at the esteem level, we start to understand how great of a database we are. And we do that first off by exposing all relevant metrics at appropriate levels of granularity. So in this case, 1 second granularity for immediate needs and very KPIs that are very critical to understanding how our systems work. Do we even do predictive? Can we find problems before they happen and address them and remediate them automatically, ideally, but even manually before they become serious problems? Do we understand capacity? Do we understand the correlations and what those capacity predictions are going to look like? And do we track when those workloads change because of 3 new features introduced per week and the inevitable change in what our capacity predictions and correlations or coefficients are going to look like? Have we trained our developers to write decent SQL or to get rid of that shitty ORM that they implemented because they're lazy? That's a joke. Developers are never lazy. Okay, the good ones were lazy. And can the system automate those and automatically remediate the faults that we're building our system to manage without us ever having to worry or care about? So then finally, we get to self-actualization, our top. This is the holy grail of our systems. First off, are we using the right data store? If we're using Mongo for some mysterious reason, are we using it appropriately, or should that data be in a relational data store? Do we have the right feedback loops so people can understand the impact of their code, of their infrastructure changes, of their architectures on the data stores? Are we supporting experimentation and data-driven decision-making? And finally, is the mission fully supported? Is this database the best database it can be? Does it go to sleep at night happy for being the database that you built and created? So that's the hierarchy of needs that we build and we focus on in building these systems that we manage. It's pretty cool, right? Charity's awesome, by the way. I would definitely suggest you follow her because she's much more clever than I am to create that hierarchy of needs. So what do we design for? Again, self-actualization, our mission objectives, function, not form, making sure that we're picking the right database, not the cool database, not the easy database, but the right one, that we design for operational manageability of systems, and that we always remember the database needs hierarchy. So what does that look like day to day? Well, as I said, we're hopefully building platforms, self-service platforms for our engineers and our architects. We're not building special data stores. So if I'm looking at bringing Postgres as a system in my environment, I should ideally be testing and building standards for Postgres clusters that can then be put into configuration management and automation for anyone who needs a Postgres environment to kick out and start working with. So I'm not building it for them anymore. I'm making sure that their catalog is kept up to date on the databases that we're ready to support and that they're given the ability to build it themselves. I'm going to teach people about the databases and the features that they have to work with, whether that's how do I effectively partition data in order to manage these large data sets, whether it's telling them not to put stored procedures in the relational databases, but to put them at the application tier, or anything else that you'd be teaching and educating people on so that you don't have to always make the decisions for them. And we're integrating with full company-wide services, which means that we are effectively leveraging monitoring systems, automation systems, configuration management systems, et cetera, by us. Validating those acceptable configurations, testing and benchmarking, making sure we understand when we're going to start hitting problems and we can preemptively avoid that, and finally documenting and sharing the standards by which the rest of the organization should utilize these systems. So then, a day in the life as a database engineer for deploying infrastructure. Well, at this point, our job is to make sure configuration management is always up to date. So at that point, we should never have a custom special config file. Our DDL should be checked in as well, everything else. We are making sure that our automation platforms have the right recipes, the right playbooks to set up these clusters that we've designed, benchmark tested, and approved, and we're handing that off to other people to use. We're also working with our developers directly in their Agile teams. So here, just like any other artifact that people would be putting in for configuration management into the systems, we're checking in our schemas for version control, giving the developers and the deployment teams the ability to push forward a schema or push it back, identifying when we can't give the ability. And what do I mean by that? Obviously, we've all have tables that are just too big or too fragile, too busy to let DDL automatically run against. So making sure that we do get flags and hooks to telling us when someone has checked in a change to those tables so that we can jump in and maybe do some advanced scripting for the deploys rather than letting a Rails migration go in, do an alter on a 20 billion row table and watch the hilarity ensue, as it inevitably will. And we're teaching the teams how to do that too, so they know when to bring you in, right? It's amazing when you actually get to the point where your engineering teams know how to run explain plans. They understand cardinality, they understand the locking and DDL in the systems, and they can come to you and say, hey, I'm about to make a change to this table, I need your help with it, versus you having to look at every single DDL and DML script and give your advice on what they should do with it. And finally, we're working with quality assurance engineers and developers to build test plans, right? Their unit tests you're not going to be so involved in, but the testing frameworks, you actually can go in and do some of the checks on making sure schemas are right, helping them design their integration and acceptance tests so that they can do safer and safer deployments. And then finally, we're getting these systems in the continuous deployment cycle to done, meaning we're giving people appropriate documentation. We're giving people appropriate playbooks for incident management and problem management. We're integrating everything and getting it into our ops viz stacks, so anyone can look at our database logs and our query logs and our time series metrics and make decisions for themselves without us. We're making sure that everything that we do is testable and that even doing tests like backup tests, continuous backups, has anyone gotten to that point yet where you're always recovering a backup somewhere just to make sure it works and it's safe? Cool. It's fun, right? It really helps you sleep at night knowing that you always know that your backups work, even So continuous backups is incredibly fun. And then, yeah, like I said, the biggest part of this is making sure that everyone can see the results of their changes, their ideas, their impacts, their development by looking at the databases. And eventually what happens is the operational visibility stacks become so incredibly big that we're database engineering our own ops viz stacks, and often the data we're building for monitoring and for instrumentation is bigger than the data for our application, which is also probably when we'll want to hire Serconis and not deal with it ourselves. So that's 2 plugs I got in. Robert can't be mad at me any longer, whoever's from OmniTI. So then finally, what does it look like here? Well, attending scrums, actually participating in them, committing our deployment scripts to the code base. There's a little redundancy here. I do apologize. And finally, monitoring the commits that are happening into the code base to jump in there ourselves. Finally, there's maintenance. Maintaining the pipeline, right? Not only maintaining the data stores, but checking the flow of it. Super proud of my the data must flow slide. I'll show you before I even get there, because I think it's pretty cool. Making sure that backups are always being recovered. Helping people with change management and getting systems in there. Helping people with incident management and capacity planning. These are all the things we're doing day to day. So first, the data must flow. We have to understand and be able to interact with our data brokers, whether Kafka, Kinesis, Redis, if you're so traumatized as to run Redis for this. Our real-time analytics systems, our batch processing, our ETL, our caches, our search stores. All of this is stuff that we have to understand because it impacts our systems, our data stores. They are our data stores. Again, backup and recovery. I will always have extra slides for backup and recovery. At a change management level, making sure that we support business velocity. Change advisory boards are horrible things, and we want lightweight change processes, but we need to nonetheless have them. So figuring out, that's one of the things for me that has been at the core of finding the art of being a database engineer, particularly in risk mitigation, is recognizing when I can be a little flexible and change. Every change has to be documented, right? Anyone who doesn't do that and who just puts changes in production should have their hands cut off. But if we can get it documented, if we can get it tracked, why don't we be a little flexible for the business, get things out more? And we do this by understanding when risk is large and jumping in at that point. Over time, hopefully, almost every change we do is low risk, and then we just play Quake or whatever while people are doing all the work for us. And that is, I think, 4 hours of Quake time a day would probably be the database engineer's ultimate goal in doing this. And it's all about exploiting the constraint to get there. Incident management, again, for this side, we want to make sure that incidents don't happen, right? We want to build systems where we can predict them and that we can then not have to worry about the actual incident itself. And when they do happen, we want to make sure that they can be automatically remediated and managed before we have to jump in. And then you're going to have that last bit when you always have to be there, right? There's always going to be problems that you can't solve with automation. There's always going to be problems that your SRE teams can't handle because of the depth, and that's where you always have to be ready to jump in and get deep into the databases that you are an expert at. So how do we do this, right? This is the biggest components that I feel like I want to make sure people understand. And it's prescriptive, but it's still vague, which is probably 2 words you can always use to describe me. But first off, getting your database engineers into your Agile flows, right? Just getting them into the day-to-day stand-ups, getting them into requirements grooming, making sure they understand all the feature sets that are not just in the current sprint, but that are coming forward and that they are participating in that requirements gathering. You should learn your software versioning system. If you haven't traditionally worked in systems where you've committed code to Git or something similar, well, that's probably a really good place to start broadening yourself as a database engineer, is understanding how to commit your config files, your DDL scripts, anything else into version control. Learn your testing frameworks. You should be able to jump in and build your own automated tests so that when you run DDL, you can automatically know that every object you expected to create is there. So that you can run explain plans and verify that indexes you've just built are being used in an automated fashion. So that's usually where I would go next in that. Study the language itself. Even if you're not an object-oriented programmer and you never want to be in your life, understanding the framework, understanding the drivers and the ORMs and how they interact with your system is, again, a place where you can really start to get a better connection with your engineers and become a bigger contributor and more components of the software development lifecycle. And finally, teach the engineers. On the systems engineering side, you can work with architects more, push yourselves on your architects to design data pipelines together, make sure that everything you build is architected and communicated and documented, that data standards are designed and shared with everyone else. If someone else traditionally does this for you because they are the architect, forcing yourself on them and just say, I'm sorry, I need to be part of this and I will stalk you until you allow me to participate. Learn the entire stack, maybe not all the way, but understand how Nginx is being used in your environment and what that could do. Again, understanding the ORMs, understanding the load balancers. You might not ever get a deep proficiency in any of them, but if you can get enough breadth to just understand their interactions to you, the TCP/IP connections between them and how that works and how that impacts your systems, that broadens you as a database engineer. And again, teach what you do to everyone else. On the operations side, build up your scripting chops. I'm teaching myself deeper Python right now, and it's fun and exciting. Learn the build and deploy frameworks that people are using, TeamCity, whatever it is that you're doing to get the change out there, understand them, being able to deploy code yourself. Be one of those folks who can go in, write some code, even if it's just a hello world page that no one would ever click, and get it all the way to production yourself without anyone else. Learn how to write playbooks in Chef, Puppet, any of these. And understanding the orchestration patterns, right? Not just understanding on your level what needs to happen in what order, whether you're containerized or not, but to be able to do it, to understand the entire flow that happens to build these distributed systems you're working in. And finally, participate in the postmortems and the failures, and plan, learn from that. On the deeper dives, I would just say understand, if you have the time, understand math. This one for me, I learned most of my stuff self-taught. I don't have a college degree, so I had to go just get some statistics textbooks and spend a month of horrible evenings slamming through them so that I could understand how anomaly detection worked, how capacity management wasn't just this linear fun world. Dive in if you don't understand that, and it's great. Obviously, this being, Serge, Theo has amazing talks on this. He's really good at this, so reading some of his stuff or watching his decks are really useful. Write and push code, answer customer service phones, understand, I know it's, the Tony Hsieh cult way. I am from Vegas, but I do believe it helps everyone to answer the phones and understand the business from the user's perspective. Dive into your network layers as deeply as possible and understand TCP/IP, which, it's much deeper than I think anyone ever thinks. And if you can get to the point where you understand it, it makes you, it's a force multiplier in your ability to be a quality database engineer. And then just, teach everyone about the data itself. ERDs maybe are, painful to build and to look at if they take a whole page in your development room, but, taking the time to explain to people what the data looks like, why it's important to the business, just to continually educate will make you a better engineer as well. So I said I would talk slow, but I think I lied. Do we have any questions? This is, it can be anything. Yes, sir. Right. So the question was how, if you're supporting multiple teams, how do you do time management on that? And time management for me has always, as I've managed database engineers, it's one of the critical skills that has to be developed. Obviously, in the beginning, what I will try to do, I don't like multitasking more than 3 things at a time. And I always consider one of those things as a placeholder for just surviving in my organization, which means 2 teams get my attention at any one time. I like Kanban for it. I don't know if you've worked with Kanban, but I find just managing that flow is incredibly useful. And just people know there's a backlog, and you tell the 3 4 project managers relying on you to fight it out in the backlog, and you just keep your work and process tight and small and recognize that you can't support more than, like I said, if one thing is focused on organizational development, you really only have 2 other paths you can work on at any time. Has Kanban worked for you? It's challenging. I find Agile's great for software development, Kanban for operations, and our day-to-day jobs are very emergent, right? We don't know what's going to happen that week. We can't plan a sprint. We can't plan a day, much less a sprint. So I find Kanban incredibly useful for managing that emergent workflow. And with that, if you have multiple DBAs, dividing the duties so that maybe one week one DBA is just focused on engineer interfaces and data modeling, one's doing incident management and on-call, and one's doing tickets, and just let them focus, because focus is the key. Multitasking is the devil. Any other questions?
Right here.
There and then there.
Is this working? No.
Yes.
Okay.
Well, I can hear you.
So the question I have is, I too have seen how the database, our DBA role is changing. And for me, the outlook that I'm seeing is that as our organization moves into the cloud, there's a lot of database as a service. Now, I wouldn't necessarily put my largest databases on a service. I'd rather see the database administrators focus less on the smaller databases that need less care and feeding. In our organization, we had a lot of MySQL servers pop up that the database administrators don't want to touch. So in a new role, where do you think the database as a service databases should get managed? Do you think that should be managed by just operational people because it's more of a, hey, I can click, put it on a schedule, I can do easy restores, or do you think that should still be part of a database administrator role?
Great question. I think the commoditization, anything that can be automated should be, and then hand it off to operations teams or SRE teams. There's no reason for it. Our depth as database engineers really needs to be on the data. So it needs to be on querying, on data modeling, on dealing with corruption, all these really advanced things that you can't automate. RDS can't do that. So I love the concept of RDS because it lets a database engineer focus on the data. Until I have to figure out what's swapping or what the kernel's doing or run a TCP dump because I have no access to the operating system at all. So I don't think that the database as a service is the devil. In fact, we ran the Obama campaign in 2012, all the front-end systems on RDS. We ran the Call of Duty leaderboards on RDS for years with no problem. And it does focus you, but I don't like the ones that are like Amazon's RDS where it's so transparent you can't see what's in the operating system. So I think until database as a service gets to the point that it can give us a level of transparency that we can trust the automation, we need to automate it, give it to the operations engineers and the on-call folks, and again, just continually get us to just focusing on the data more and more. Does that answer your question?
Yeah, it does. Thank you.
Cool. You're welcome. Yes. Were you the one over there with the hand up?
I was, but then I walked over here.
Exercise is a beautiful thing.
So I migrated. I'm a DevOps consultant, and oftentimes I'm working with teams and trying to get them to play together a lot better. But the DBAs are just this immovable object.
They're angry, bitter people.
Everybody just assumes there's no way that they're going to integrate into this.
Yes.
How do you get buy-in? I mean, like the things that you had on your slides, I'm like, oh, I love that, and you obviously want that and are living that life. But how do you approach a DBA that's the old school type and start to get them into a convert?
Bring them food and beer is the first thing, and talk to them over that. So I spent, up until last year, I spent about 8 years building a remote database managed services team. We competed a bit with OmniTI, so similar concept, right, or with Percona. And I found about half of the database administrators simply wouldn't change, right? I literally told them, if you do not evolve in this way, I'm not going to need you in 2 years, and you're not going to have a job except at places that don't automate anything and are horrible places to work at, and they still wouldn't. It takes showing them, and it takes incremental steps. So if you focus on one thing at a time, I would initially focus on automating infrastructures, right? because that's something everyone loves automation until they don't. And you can usually get someone behind on that. So then if you can get to the point where you could push button deploy systems, that leads you to the next step, which is continuous delivery. Not continuous deployment. You don't want to, they'll run screaming at that point or they'll stab you, but at least if you can show them integration-wise how rapidly, it's like, hey, if you let people do this, the changes come through and you can do this, this, and this, start to give them tools. So as a DevOps consultant, maybe your job is to start showing them how they can get a list of all the commits in dev, and they can start understanding with their knowledge of the objects in their databases when they have to get involved. But it really is an incremental process. Some people won't ever want to change, and they can go work at IBM or a place like that. Anyone here work at IBM? Thank God. Okay, so but yeah, it's going to be incremental. Some people you'll just have to leave on the wayside, and I think it's important there to also talk to their managers, right? Because the leaders need to know that they have intractable staff who aren't willing to change and evolve, and maybe it's better to find a better DBA. And I know it's hard finding a good DBA at all, so people don't want to get rid of the ones that don't want to change. But they're probably, in my experience, at least 25-30% who are they're going to have to wait until they are completely commoditized out of existence before they're willing to do it themselves. Yes.
Hi.
Hi.
So you argue for this more agile approach and not being a gatekeeper, right? And that's great. How do you consolidate that with mistakes being more costly in a database? Not only accidentally deleting stuff, that's obvious, but you mentioned like this one big table that's like too fragile to touch, and then if you model data wrong, then it's hard to change later. How do you integrate that with a more agile approach where you let developers do things and then measure afterwards, kind of thing?
So specifically on agile data model development, I definitely don't advocate for not knowing what's happening, and I think that is a big difference. Overseeing everything, keeping an eye on it, participating in those conversations, recognizing that is absolutely critical. And particularly in an agile environment, the data model is one of those places where you still don't want to get wrong. You want to be able to additively iterate, but a mistake can be incredibly costly. Where I'm at right now, we made that mistake in letting an engineer choose Mongo, and now we've lost 2 sprints to migrating it to Postgres because it's like, no, it was actually a really bad choice. So in terms of that, I think you can additively iterate, and I think it's just a matter of picking your battles. And that's, again, where I like to, to call out, you should be able to interact with a code base in such a way that you understand when the places you need to focus are coming down the pipeline, and you dive in deep. And building those relationships with the developers, teaching them how fragile some of those systems are, so they don't even want, they will come to you. But I'd never advocate not knowing, not letting, it's not a playground for developers by any means. It requires a significant amount of education and a significant amount of relationship building to get to a place where you can trust your developers to do 80% of the work in the databases and you do the 20%. Does that help?
Yes.
A little vague answer, like I'm running for president. Any other questions? This is awesome, by the way. I like the amount of questions. Okay, cool. I would say I'm going to be around for stuff after, but I have to run to the airport. I will make sure the slides are available to OmniTI and also my contact information. So if you have any other questions or if you're interested in collaborating, just drop me an email. And thank you very much for the time and the attention.